I do know moms now. So my sons are in right now grade 7 and grade 5. Like there's some girls in when my now in grade 7, he was in grade 6. Girls were getting their period when they were 10.
Yeah.
And even younger, there's been reports of girls getting their periods earlier and earlier, like 8, 9, 10, which is a little ahead of what you would expect for the onset of menarche. And it makes me think about potential accelerants or things that are maybe accelerating either the sexual development of the child or the acceleration of the aging of the egg. So now we are starting to get this coordination of menses, or this, the menstrual cycle for girls earlier and earlier. Do you have any I mean, I know we're going to talk about environment, and this might be a good stepping stone into that. But is there what are your observations, or what are your thoughts, or what does the science tell us in terms of why this might be happening? Do we know why girls are getting? It seems like girls are getting their periods and starting that age of men, like that onset of menarche, earlier and earlier.
Well, what you're talking about, this early puberty, or decreasing age of puberty, is definitely a phenomenon. It's been studied for quite a while now. And I want to mention it's not just the age at menarche, but it's also age of breast development. And it's particularly dramatic for breast development, which is earliest, by the way, in African American girls in the United States compared to Caucasian girls. Socially and psychologically, this poses real challenges, because these very young girls of 8 and 9, looking like they're, 16?
14, yeah, 16, yeah, yeah.
They are not able to handle psychologically the inputs that they're getting from males, and it's actually a serious problem. So, apart from the physiological consequences, as you said earlier, sort of shifting the whole healthy egg period earlier is going to make it harder to get pregnant later. And on the other end, there's phenomena of fewer and fewer good eggs being available when people want them, called premature ovarian failure. And it's increasing. So we have shifts in this, picture of reproductive health and reproductive timing, which is, not good for our species, I think, in terms of ability to conceive and the fertility rate and so on and so forth. So did you want to switch to causes of all this, or should we talk about the males first a little bit?
Yeah, let's talk about the males. So I think this is important because you had a study in 2017 I'd like to discuss, and I'd like to talk about sperm count. I'd like to talk about testosterone. So let's start. Let's go to kind of the rate of change, we'll say, or potentially decline in what we're seeing in our beautiful male counterparts.
So the question of how much sperm a man has, how much sperm he produces, and whether that's changed over time, that's been around, I would say, for 30 years, scientists discussing this question. And the first paper that really got people's attention was 92. Okay? So, and it came out of Denmark, where a lot of this work has been done, pioneers really in this area. And if you think about 92, is reflecting on sperm counts earlier, going back, all the way to, say, the 40s, you're talking about a paper that's coming out in 92, but the problem is there for a while, right? A long time, actually. And what this paper said is that over 50 years, sperm count has decreased 50%. 50.
In the 90s, this was reported.
It was published in 92.
Yeah.
Went back 50 years, okay?
Okay.
And so this was a very controversial. And many people were skeptical, and I was skeptical. It sounded too big, 50%. And when I looked at the paper, I didn't think it really convinced me, right?
Can I ask a question? I'm sorry to interrupt you. Is it total sperm count or is it sperm quality? Like, are we looking at agglutination? Like, what are we looking at when we say sperm has declined?
Okay. So all of these papers and everything I'm going to say about this has to do with number.
Number. Okay.
Not motion, not shape. Just a quick reason for that, because the methods of counting sperm have been the same for a long, long time. Okay. But the methods of measuring motion and shape, morphology, have changed. Okay. So you can't really separate the methodological changes from the actual physiological changes for those things, right? So that one's much more difficult. But count, we can be talking about concentration, which is how many are in a, standard square under the microscope, or how many are there in a whole sample. So there's total sperm count and sperm concentration, and they're kind of used interchangeably because the amount in the sample, the volume, is not actually very sensitive. It hasn't changed very much. So that's one thing that hasn't, we don't have to worry about. So we can kind of talk about count and concentration interchangeably. Okay, and let me just point out that when I say 50%, you didn't gasp, and most people don't, because it doesn't hit you. So I want to give an analogy. If I told you that IQ had decreased 50%.
Oh my God. That's crazy. Right? Yeah, no, I get it. I guess. Right? I apologize for my lack of response. Yeah.
I do. Oh my God, you really freak out, right? Yeah. But people don't about sperm count. And one of the reasons is that men make a lot of sperm. There's just
that's what I think it is. It's like, well, isn't there like 40 other billion of them? Like if we decrease it and it used to be 100 and now it's 50, like we still got 50. Like that's sort of my thinking, but that's not right. That's not
one
right.
Reason. Yeah. So maybe I'll interrupt here and just say why that matters for fertility. Okay. So if you look at I remember we talked about fecundability, the ability to get pregnant. Okay. So if you look at a population, you see how long it takes them to get pregnant, or you see how many conceive in one menstrual cycle of trying. Okay, let's focus on that. How likely are you to get pregnant in a single month of May, for example? All right. If the sperm count is high, it really doesn't matter for that probability of conceiving, whether it's 70 or 90 or 100 or 150. There's just a lot of surplus, right? So in that sense, count doesn't matter. If it's really high, it's extra, if you will. It doesn't matter. Once you go low, then it matters a lot.
It really matters, yeah.
It really matters. And if you go to 0, you can't conceive at all. If you go to very low numbers like 10 and 15 million, it's still a million, but it's still 10 and 15 million, then it's very difficult to conceive. You're subfertile, you are actually called infertile, right?
At 10 to 15 mil.
Yeah, I mean, the WHO standard now is 15 million per milliliter. We can talk about that if you want. But
yes, I do want to talk about that.
Even the low numbers are millions. And with millions of sperm being produced all the time, by the way, men produce sperm all the time. It takes about 70 days to produce a sperm. Unlike women who are born with all the eggs they're ever going to have, men keep making them, right? And so why should we worry? There's always going to be more. But we should, because now we know that when that number drops below about 45 million per milliliter, then the chance of getting pregnant drops pretty quickly to 0. So that's why 50% drop matters a lot.
It matters a lot. And where do we have global averages, or does it vary by country or temperature? Do we know what the global mean is?
That depends on time, right? That depends on when. Okay, that's what our studies are about. So let me go back. So this paper came out in 92. And like I said, I was skeptical. And so I did what every epidemiologists might do is to say, if you're skeptical, why? And are there factors that might explain this away? So, for example, maybe studies in the past had younger men, right? And that might matter. Not a lot. I told you men are not so sensitive to age, but that could matter. Maybe studies in the past used different counting methods. That could, so maybe the old methods back there in 1940, who knows how careful they were? Who knows? Maybe they counted higher and now we count lower. That's very, very possible. Maybe men now are more obese, more likely to be obese. Obesity is a risk factor for lower sperm count. And yes, men are more obese. Would that explain it? Maybe men these days are smoking more, smoking lower sperm count, and so on and so forth. So you can ask all these questions of what could have produced a decline other than physiology changing, right? And that's what epidemiologists do. They look for these factors.
For 50 years, you can't, there's nothing that you could explain from a genetic.
No.
There's nothing that you can explain from a inherent intrinsic reason why that's happening. There has to be something extrinsic. Yeah.
That's exactly right. So it has to be something in the environment or something that is in the measurement itself, or it could be something in the men. Okay? And another possibility, which I didn't mention, which is actually a real scary one, is that who are these men? Who were the men that were in the studies in 1940 versus the studies in 1990? And maybe the men in the past came in because they were proud of their fertility, or they were getting a vasectomy because they had too many children.
User bias, right? Right.
Recruitment bias, selection bias, and then men in later years are coming because they have concerns, about their fertility. Well, they'll have low count. So all of these things are important. And so what I did was I said, okay, I'm going to do this. I'm going to take 6 months and I'm going to get all the 61 underlying studies. And I'm going to go through every one of those and I'm going to look at all these factors. And then I'm going to quantify them and put them in a spreadsheet. Okay? And then I'm going to rerun the model and see what happens to the decline. That sound like a reasonable program?
Yes. That's what a scientist, that's what science is. It's like, let me test this hypothesis. Yeah.
Right. Mm-hmm. So we did that. And I had a colleague, actually two, who helped me. So we have independent eyes on this. And it was really a wake-up call because when we looked at the results, Stephanie, nothing had changed. Nothing had changed. None of those factors mattered. So I had to go, whoa, Another thing a scientist does is if they have convincing evidence that they were wrong, they have to change their opinion, right? So I began to say, okay, maybe this is correct. And then I did a couple of other studies, which we don't have time to go into. But the bottom line was nothing made this go away. Okay? So then I started thinking, okay, what could cause this? And like you said, it's not genetics. It's too fast for genetics. And so it has to be environment. Those are the two sort of categories of causes. So if it's environment, God, that's everything, right? But you can kind of separate them into lifestyle, things you can control, and things you can't control. Okay? And so lifestyle, I just want to say those quickly, matters. Smoking matters. Obesity matters. We can talk about more of this if you want. It matters for men and women, by the way, for their fertility. Exercise matters. And a lot of things you talk about on your podcast, I think, how to be healthy, and maintain your, fertility and so on, matters, of course, for sperm count. So lifestyle factors are important. Stress is another one, which is very difficult to control, but it actually measurably affects your sperm count and your fertility. Okay. So we can go into that. That's another podcast, lifestyle factors.
Right. Mm-hmm.
But my work has been focused on the other kind of environmental factors. And the ones that I particularly focus are on chemicals. And why is that? Well, we know that chemicals can affect our fertility and our reproductive function. And the particular group of chemicals that are most concerning are those that have the ability to mess with our testosterone and mess with our estrogen. And why? Those are the sex steroid hormones. Okay. So actually, any messing around with our hormones is a bad thing. And, there's hormones that mess with your immune function, and there are hormones that mess with, change your, your BMI, and so on, obesogens. But the ones that I focused on are those that can affect the reproductive system, and those are the steroid hormones, testosterone and its analogs, and estrogen, and there are other steroid hormones, as you know. And so it was a really big wake-up call beginning at about 1970, actually, that there may be things that are inadvertently changing our body's hormones. There was a drug that women took to prevent miscarriage. It was called Sylvestro. Have you heard of that? Yep. And this drug did terrible things to the offspring, including causing devastating cancer of their reproductive organs, right? And this was an estrogen. This pharmaceutical had the ability to alter estrogen in a very profound way. And then it had reproductive effects, and it had cancer effects, and it had psychological, it had a lot of, you can't mess with one system in the body without messing with them all, actually. So when people realized that this drug, called DES for short, could do this, then they started asking, what other chemicals could be estrogens? And that was the first start of considering chemicals in the environment that could affect our hormones, which became a wider class called endocrine disrupting chemicals, or EDC. Let me stop there, because that's a lot for people to absorb, and maybe you can channel some of their questions to me. What do you think people